And now it's time for the latest exciting episode of Doz's Television Workshop.
Hello and welcome back to Doz's Television Workshop, where today we're going to be taking a look at this Monitor Audio Mas W200 Subwoofer that's no longer woofing. Let's get into it. Well, this is a bit of a thing. This belongs to a very good friend of mine and one of my ex-employers, actually, a gentleman by the name of Brian Harrod. Brian used to have a television and video business through to the mid-2000s, I think. Insert picture here. And he was known as BB for TV. Anyway, she sent me an email the other day and said, I've got a problem with a subwoofer. Could you have a look? So I said, yes, sure. I think this panel pops off somehow. But the problem is, for a while, it stopped automatically coming on. And it's just, it's automatically supposed to come on. And it stopped doing that. You had to switch it off and back on again. And now it's not doing anything at all, apparently. So I think he might have been in there, because we've got a screw half hanging out. That's a sort of coarse threaded wood screw affair. So let's just wick the others out. That one got a bit rusty. Right, let's see what horrors lie beneath. Have I got all the screws out? I think I have. It's not very keen, is it? Let's equip ourselves with a spudging tool. Is this coming out on camera? I think so. I've had to move cameras around because it's a bit of a behemoth of a thing. Could be tricky. I suspect it's got a gasket up behind it. It's stubborn, that's for sure. Oh, I think I might be in. Yeah, there we go. Starting to make some inroads. I wonder if it's actually fixed underneath somehow. Let's just tilt that forward and have a look. No, there's no screws in there. I can see a speaker. You've got two speakers by the look of it. Left and right there. Just see the edge of the speakers there. Crikey. I think, yeah, it's stuck. You can see where the vinyl has curled up a little bit there. And that's giving us a little bit of an issue. Come on. I wonder if that screw has got to come out. Ah! There we go. Right. Let's just have a little look inside. Oh, it's one speaker. Something's going up to the top there. I think that's that LED just here. And one passive radiator on the other side. Right, that's that disconnected. Let's disconnect the speaker. For future reference, the red lead is towards me. And the black connector is stubborn. Very stubborn. Risk of doing some damage there. Let me just have a peer inside with a torch, see if I've got a latch on there or something. Yeah, there is. Okay. There we go. Right. Put my torch away. So that's our control amplifier and everything in there, and don't weigh a lot. This is going to be some magical Class D thing, isn't it? Right, I'm just going to pop the speaker out of the way for a moment, and yeah, let's have a look here. And we've got a wire grommet there, but it's been sealed up. Let's hope these disconnect from the PCB in a sensible manner. Right, so some screws. We can see which screws are holding that lid on. So, right, reasonably coarse thread screw, countersunk head. My screwdriver needs charging up. Right. Okay. Oh, right, that has just unplugged itself. Where on earth from? Oh. There's a smell, a sort of chemically smell. Now that LED obviously plugs in there. Okay. Our speaker does in fact disconnect from the amplifier board itself. Alright, so what have we got? A switched mode power supply of some description, and I have to say I'm not very happy with those capacitors. They've got fractionally domed tops, do we think? Certainly that one there doesn't look ideal. What's under here? We've got a bit of a choke. Right, so let's disconnect this mains here. And I would imagine our problem is probably power supply related. What have we got on here? We've got a big electrolytic here. We've got some of those unpleasant surface mounts, although I don't know how old this is. They only suffer a certain sort of vintage, so let me just have a look. Can't see any signs of leakage from that. Okay, let us remove this power supply and just, oh, okay, right, there is whatever this resistor here. You can see there that the glue is quite discoloured because this resistor has been very warm. Righto, well, let's take it apart and see if we can't have a go round with the ESR meter and see what's giving us problems, if anything. Right, I think that's the power supply all disconnected. We've got some screws here. What's that? M3, 8mm long, domed head. Same. And I did say that was going to need charging up, and it has in fact gone flat. So I shall get my suitably sized screwdriver just to finish the job. This screw is a little bit different. It's got a wide flat head on it, same M3, same length, just with the big wide head on it there, look. Okay. Oh, I've jettisoned a standoff there. I think maybe I've undone more screws than I should have done there. Yeah. Okay, that is one of those M3 cheesehead things, so I'm just going to pop those back in there because they're holding on It's holding on that standoff, so let's just pop that back on so I don't lose it. Okay, right, into the power supply. That resistor there, you can see that one there is very discoloured. He's been very, very warm. I'm just going to switch the desoldering tool on, and we shall just desolder that. This print around here does look a little bit abused. Did I just feel a little tingle there? Let's just see what we've got in the reservoir capacitors, shall we? There's our bridge rectifier. So we got no. No, nothing in there. Just paranoia. Right. Crumbs, there's no seeing what value that once was. Very difficult. It's R23, so let's give it a measure. I mean, if it's still a preferred value, chances are it's probably alright. If it's gone high or whatever, 50 ohms. So, could that have once been 47 ohms? I think it could have been. What do you think? I reckon that could have been 47 ohms. I'll Google some part numbers in a minute and see if we can come up with something that gives us a clue. Let's just put the ESR meter on these errant looking caps around here and see if they're any good or not. Out with my peak. So where are they? Over here somewhere. That's that one there, I think. In circuit or leaky, not helpful. There's another one there, I think. In circuit or leaky. And this one is over to here, which is looking like those pads there. $1,296, 12,960 microfarads. Nah. No. Right, so we need to take some of these out. So we'll start with that one that's got a mad value to it. I'm just going to get rid of some of this glue. I'm going to be a bit careful because there's an inductor next to it. I don't want to damage the enamel on the inductor. It's probably just an output filter, but let's not do unnecessary damage. Okay, let's come away. Right. This is C5. Let's add a bit of fresh solder into there. It's not keen on coming out. The jacket's just come away on that. It's where it was glued up against that inductor. Looks okay. Doesn't smell funny, so let's get the peak on that and see what it measures like. Let's get a blob of blue tack just to hold it down. What value is it? 220 microfarads at 16 volts. Low ESR. Open circuit, low capacitance. Let's just try that again. No, 224 microfarads and very low ESR, so yeah, he's fine. Okay. Polarity, by the way, is clearly marked on the board. Nice to see. Right, now the one next to it is the one I'm most suspicious of. So let's just pull that one, measure that. Don't like this print much, it's pretty weak. Right, physical inspection, yeah, looks very good. How does it measure? Capacitance not measured. 225 microfarads, 0.11 ohms ESR. I think he's probably okay. And in fact, I think it's an optical illusion of that top being domed. Yep, 220 mic, 16 volt. Is not guilty. Looking at this, I think we've got more than one supply. I think we've got two. We've got two connectors for a start. One beefier one, which is going to supply power to our Class D amplifier, whatever that is. And this over here, which I bet is for the audio stages and the thing that brings the shooting match out of standby. So, right. Let's take that third one out that wouldn't measure either. Can't see it now, it goes the opposite way. Ground is that side. There it is. That's the fella there. Got it. Once again, looks serviceable. "100 microfarads, this one. Indeed it is. No, right, we've drawn a blank there. I think these are the output filter capacitors for the standby circuit, hence low ESR requirement. Right, that's got all of that back together. We've got another couple of little capacitors here, 100 mic, 16 and same again. So let's see if we can snag those in circuit. Yeah, that's absolutely fine. That's 1,000,000 farads again, but it's across a coil, so it's probably resonating slightly. Now we've got this horrible thing up here. So a little measure of that. "20 mic at an ohm." It's only small. If that's 22, it can stay put. It is. Yep. Making rapidly no progress at all here, are we? Let's have a look at these gargantuan output capacitors here. These two are in parallel, so I expect to get double the reading. 963 mic, so they're 2 lots of 470 maybe? They are indeed. And last but by no means least, a mains reservoir. 200 mic would ring about right. What's this one? Again, 200 microfarads. I bet they're 220s. Yep. So, we've got a bit of a quandary, haven't we? Oh, there's another little one just in there. Let's just indulge ourselves. It's there, C18. Ten mic. Yep. Alright, so all the capacitors are looking good. So what have we got over on this part? Is our power supply running up? We've got that resistor to do something with. I wonder if the power supply would work unloaded. We could always plug it in, see what voltages we get anyway, couldn't we? Yeah, let's just stop here for a minute, go and have a look on the internet and see if I can see if we've got any schematics for this supply. Doubt it, but it's worth a look. Right, so I've been and had a look on the internet, and there are a few threads about these failing. They all point to a post that doesn't exist. I hate forums for that. But it does say the fault lies within the standby power supply, and it mentioned these 3 diodes. Here's the connector that supplies the power to the standby circuit. We've got -7 volts, ground, and +7 volts on this end. I don't know what that pin is, but there's also mention of about 18 volts on that diode there. So I think what we're going to do is, just for now, I'm going to refit this resistor. This, by the way, is 51 ohms. It's on its last, clearly, but it's okay for the time being. So let's pop that back in, solder that up, and connect it to the mains, and carefully see if we've got voltages on those secondaries. I'm just going to beep that out because the print is rather fragile around there. That's okay. Yeah, I'm happy with that. Okay, so let's quickly just reassemble. And see what we've got occurring. I'm just going to pop 2 screws in there. I'll pop that weird flat one in to start with. Okay, that is the sort of main HT rail. And that's the connector for this standby that we are most interested in. And that's the mains there. Right, we need a figure of 8 lead, and we want to be running isolated, so yeah. Right, okay, that pin there is ground, that pin there is either plus or -7, so switching on. Okay, that is +7 volts. Let's go that way. This should be -7 volts. Looks good. And then, let's say on the tip of that diode, we should have Another voltage, I can't remember, it's something like 12 to 18 or something. 19 volts. So that would sort of suggest that that power supply is at least working properly. Have we got any HT? I wonder. We do, 50 volts. So it would appear that the power supply is working okay. Right. All research, I think. Right, well, I managed to find a schematic on the internet for the power supply, and I can confirm this power supply is doing what it's supposed to do. Plus minus 7 volts on here. The blue wire that comes in there is a power good signal, or a power on signal I should say, and there's 50 odd volts feeding the amplifier board. I've got a signal from my signal generator here, 50 hertz square wave, so it should be nice and harmonically rich. And yeah, this is doing absolutely nothing. I've got it in mode on. I've got the workshop speaker tacked across the output, and it's just doing nothing at all. So I think the fault is within our main amplifier board. So whilst it's on, I'm just going to have a little look round, see if there's anything getting hot. And wow, yeah, there is. What's that? Yeah, you can see that there is something getting 112 degrees in there. That's warm. Right, let's just power down. Okay, and see what that part actually is. If I get a shot of that. Yeah, no, it's underneath that heatsink. I'm going to power back up again. Yeah, we're running. It seems to be down the side of that heatsink, so I'll just put my screwdriver in there, try and locate the part. Yeah, it's right in that area there. I'm just going to get a photograph of that. And hopefully you'll see that, but that's 100 and something degrees. So, right, we've got something getting very warm. I suppose that's good news. So let's get this amplifier out and see what that part is that's getting warm. Yeah, right. There is quite a bit of information about the power supply failing on the internet, but clearly it's not the case with this one. That was an M3 screw nut and a washer. This, by the way, was an LED I just hang in there. It is a bi-directional LED, but I just wanted to see if there's anything on there at all, of which there isn't. Right, let's just take the knobs off, undo those nuts. I got a feeling, you know, that plus 7 volt rail is probably regulated to, I don't know, 3.3 or maybe 1.8 to drive a microprocessor or something, and I wonder if that's actually missing, hence the issue. Right, we don't want to undo those two. That should be it. Right, let's see if we can wiggle it out. Probably going to want to disconnect things. Definitely going to want to disconnect things, at least temporarily. Okay. Alright, we've got a lot of glue around here. There we go. Okie dokie. There's our amplifier board. That's the workshop speaker. Let's pop that out of the way for a second. So, what we've got getting hot is right in the corner down here. So I think we're going to want to take that heatsink off, aren't we? Two washers are stuck on the heatsink. Right. What we've got getting hot is something down here. So let's find out, if we can, what on earth that thing is. Obviously that chip there is the Class D amplifier. I cannot read that. We shall get it under the microscope in just a second. Let's just have a quick buzz round, see if there's anything obviously short circuit there. There's a diode there. No. Capacitor. No. Another one here. Oh. Dead short. Right, so C76, there is a short across C76. Let's see if we can work out what C76 is doing. There's an MLCC there, going the other way. It's a 16 volt capacitor. That MLCC, I wonder if that's short. Oh, and that's going, that's our plus 7 volts. You'd think if that was short, it would have pulled the line down on the power supply. Ah, that might be just on the connector. Yeah, I don't think it is that, but it goes up there. Yeah, it's a rail of some description. So we've got something short maybe on that rail, and that's what you'd expect. That capacitor, you know, the electrolytic here is probably decoupling a rail. So have we got a short on there? We do. What about there? We do. 0.4 of an ohm. 0.9 of an ohm, so it's possibly moving in this direction. There's a via there, there's another MLCC there. 0.3 of an ohm. That one's okay. .6 of an ohm, so we're moving away from the fault maybe. Yeah, 0.3. 0.3. 0.3. 0.3. No. 0.7, so it's looking like sort of around that capacitor there, which is 0.7, which is C10. That's C13 next to it. Yeah. Could be the microprocessor itself, couldn't it? More likely to be an MLCC, I'd have thought. Our chip here is an STA309 by ST DDX. I suspect that's some sort of DSP. What to do? We've obviously got a fault on the rail somewhere. I could do something unpleasant and sort of inject 1.8 volts into that rail and look to see what's getting hottest. See what's failed. Yeah, I reckon this is probably the regulator down here, hence it's getting hot because it's trying to drive us short. So if we drive it at 1.8 volts, we shouldn't really do any damage. That should be the sort of maximum voltage we would see on something like this. We could look at, of course, what the STA was it 309, 307? STA 309A. Let's Google that and see if we can't glean some information on it. Sure enough, the data sheet for that IC is available. It's here, and it is a digital signal processor. The important part of it is it's a 3.3 volt part. So here's my plan. I'm going to attach a wire to that rail, which is indeed the 3.3 volt rail, and I'm going to put a little current into it and see if we can spot what's warming up. Yeah, this is sort of kill or cure, really. We can't be doing any damage because everything on that chip is sort of related to 3.3 volts, and the short certainly seems to be around here. One thing, are there any obvious issues with the soldering, etc., around the chip? No, it all looks good. Right, that's my plan. It's a little risky, but we have no schematic, we have no chance of getting a schematic, and this might just be an easy fault finding method. Used to do this back in the day when we had failures on a piece of equipment that one of our, where I used to work, the guy used to pop 5 volts on, and then back in days when things were 5 volts, and works better if I switch the soldering iron on, and yeah, he used to watch what got warm. Days before digital infrared cameras though. Right, so that's my point that I think is the fault. I'm going to attach a little piece of kynar to it. I'm going to need the seeing eyes for this. Really wants a microscope on the job, doesn't it? Right, so let's just trim that off. It's quite a thin piece of wire, so we won't be able to pop much current into it. Otherwise the wire will be hotter than everything else. Let's just check that is where our short exists. And it should go back to the middle pin of that connector. Which it does. Good, okay. So I'm just going to strip a bit of that away. Ah, it's come off, damn it. Should have stripped it first. Right, let's just tack that back on again. Okay. And we need to pick up a ground from somewhere, but I suspect everything will be ground, won't it? That is definitely ground, that big one there, I think. So just confirm. Yeah, it is. Right, excellent. Okay, workshop power supply on. I want, well, let's go for 0 volts. I'm going to put the current limit all the way up. I want some crocodile clips. Use these ones for a change. So that's red to the thing we think is short circuit. That's down to ground. I'm already pulling 700 milliamps at 0.23 of a volt. So yeah, something is short, isn't it? Let's see if anything is getting warm. Oh. No, I'm seeing a reflection of the light above the bench. Let's just turn that down. Ah, it's warm. We may have to wait till that goes cold. But yeah, I can't see anything. That glow you can see in the camera there is just the bench light, I think. Oh, what's that? No, that is just a reflection of whatever's getting warm. Let's turn this voltage up a bit. Right, there's 1300 milliamps flowing. Is that something at the top there? I'm just waiting for that light to cool off. It's interfering with the camera. Right, let's turn that up a little bit more until we get some sort of a result. Right, we're moving 3 amps now. Yeah, you can see, oh, something there's getting rather warm, isn't it? You can see our wire is getting warm. So what's that down there? Looks to be an MLCC down there. Let me see if I can't just identify that. Oh, it's looking like it might be the DSP, you know. Trouble is, this DSP is programmed. It's a programmable part. Is it that part there? No, the MLCC is cool. That's the DSP. I'm going to take a screenshot of that so you can see. That is bad news, I think. Yeah, it's one leg of the DSP that's getting red hot. Oh dear. Right, well, we can sort of prove that by making a measurement. And that is going to be game over if that's the case. Because like I say, this is a programmable part and we don't have the program. Disappointing to say the least. It looks to me it's coming off there. Yeah. Oh, rat bags. Yeah, that looks like it's pretty terminal. An interesting fault finding procedure, nevertheless. Brute forcing some current into something. You know, we've made sensible. This isn't even warm. That camera is very sensitive. But yeah, you can just see one part of that getting warm. I think what I might like to do is just chuck it under the microscope, see if there's anything obviously wrong in there. Let's do that. Right. Oh, what's that? Can you see that there? We've had this microscope before and I tried to get the footage and the video software throws a wobbly. Look, can you see that just there? That looks to me that pin's bridged over. Let's get a bit of flux on there and see if we can't clean that off. Is that our problem? How has that happened? It might be that the thing's got so blasted hot in the past that it's melted the solder on its own legs. It's coming. Let's try getting a little bit of desoldering braid in there. Have I got it? I think I have. Yeah, I'm just going to check all of it now. Has that been there since it was made? That would be wild if it had, wouldn't it? What's that there? Just a bit of fluff. What about that one there? Don't look at that much. No, I think we're good. Right, let's repeat our experiment. I'm going to turn that current down and we'll see what happens. Well, that short has now cleared. That could be wonderful news, couldn't it? A little blob of solder. Unless I splashed it when I put this on, but no, because the short was there previously. Right, let us reassemble and power it on, see if it works. Okay, I am connected back up again. I haven't put the heatsink on, so I'm not going to run this for very long. I have got my thermal camera ready. I'm set to mode is on, bass is impact, whatever that means. We've got a volume pot there. We are just off minimum because I don't want to blow the workshop speakers up. Right, here goes nothing. Right, we're on. Got things warming up. Don't appear to be hearing much. However, I haven't got anything getting excessively warm. How much current are we drawing? Yeah, it's about the same as before. Oh! We're working. Okay. Well, that's news, isn't it? How hot did that chip get? 47 degrees. We weren't exactly pushing it. Okay, we might have a runner. What I'm going to do is I'm just going to take my signal generator off. I'm going to put that up to 75 Hertz. Just so it doesn't sound like mains hum. Hertz, there we go. Right. I'm going to switch the output off. I'm going to put it in auto. I'm going to switch on. Yeah, I'm drawing current on the mains, although less this time. I'm going to switch that on, see if it comes on. Okay, we are working. So if I take my output off, does it automatically go back into standby? It's working. Wow. I don't know whether the mic's picking that up, by the way. There is a low pass filter on the microphone. I'm only at 70 odd hertz, but 75 hertz. Right. By Jove, I think we fixed it. Right, I'm just going to reassemble all this back off camera, put it back in the enclosure, and see if it actually behaves. A couple of things that are quite important I need to do before I do put this back together. One is this heatsink. one, it needs to go in the direction of the pots, otherwise it's not going to fit. And secondly, you can see this, if you can see this on camera here, there's a sort of rubber gasket around it, but I wonder if that has just been crushed and the original surface was insulating the heatsink on here. Yeah, look, can you see there's a heatsink pad underneath? Now, is that supposed to be isolated from ground or not? Because if it is, we need to fabricate a new sort of heatsink pad. If it is ground, we've got the possibility of a ground loop, but let's just make a measurement there. No, it is continuous to ground, but I just wonder why they isolated it there. Was it to prevent a ground loop? In which case we're going to need a bit of thermally isolating stuff, electrically isolating stuff, because that has, as you can see there, it's disintegrated. It looks like a floppy razor blade, doesn't it? Yeah, so there's that, and also there's the question of the cooked 51 ohm resistor in the power supply. Now, I just had a look in my box. I do have 51s, but I'm only going up to about 3 watts. So I've ordered something bigger to go in there. So hopefully that'll put things right. But yeah, so that's just 2 things to consider before I put that back together. So I've ordered the right resistor. I will now go and see if I've got a thermal pad. If not, I think I'm going to order something. Right, pop back in a bit. Okay, while I'm waiting for stuff to turn up, I thought I'd talk you through this schematic I've found. It appears to be more than just a power supply, just at first glance, because it was, I mean, the power supply I was interested in to start with. But yeah, here's our mains input here. We've got a fuse, thermistor to limit the inrush, a bit of snubbing, a VDR there, just to knock the edges off, load of filtration, bridge rectifier, and out 320 volts. That appears here, but we'll come back to that in a minute. It also appears here, and this is our power supply. So we've got rectified mains in, we've got a switch mode power supply controller here, a few passives, and an optocouple feedback, which appears to be fed back from the plus 7 volt rail. So I'd imagine this power supply would be quite happy running off load. And there's our plus 7 volt rail. Here's our minus 7 volt rail, and that's the sort of 15 volts. And these 3 diodes here, and these 4 capacitors here, 1, 2, 3, 4, they're that of which the internet was banging on about, that give a problem and the power supply shuts down. We've got the power supply on switch here. Also, if we scroll up here, we have this IC, and I had to Google what this was. This is a switched mode controller, a regulating pulse width modulator. So yeah, it's what it does is it gives outputs here, which then control this second part here via a coupling transformer there. Switches a couple of transistors, switches a couple of FETs, through a bit of filtration, drives this transformer, and this gives us our 48 volt output to power our amplifier there. So pretty comprehensive diagram. Not quite sure what this bit's doing. Producing another voltage rail by the look of it. Yeah. Other stuff we've got is we've got the input detection here. So this is the auto on here, auto on schematic, look. And it's just an op amp, bit of a peak detector there. Switches a transistor on via a capacitor which charges up and puts that rail on. MCP, didn't look that one up. What have we got? Oh, that's a microcontroller by the look of it. Let's just Google that, shall we? Yeah, it's an 8-bit microcontroller from Megawin, obviously. So yeah, we've got a little 8-bit micro in there doing some stuff. Looks like it's got outputs for the DSP, more on that in a second. So yeah, a little microcontroller. There's some stuff here that's obviously playing around with the microcontroller. And interestingly, this is the IC that was getting red hot when we were in fault condition. That's just a little linear regulator there, giving us 3.3 volts out. So that would have killed the whole system. I mean, there's a... what's that? That looks like possibly what's called a pot, one of those digital pop things. There's another 3.3 volt regulator. Ah, I wonder which one was getting hot. I'm going to look at that. Give me one moment. Ah, it is U7. So that's U5. So it wasn't that one that was getting hot. It was, in fact, that one. That's what I thought. So that was the one that was sweating its cobs off. If we scroll up again, we come to this lot here. Now this is our STA309 DSP. And if you look down here, this is where our short was. Between VDD and ground. How would that ever have worked? I mean, that solder splash that was on these 3-4 pins down there, that must have been just intermittent since it was made. This, by the way, STA516, that's our Class D amplifier, and it's a hell of a thing. 500 watts peak maximum power down here with the wind behind it. 56 volts, so we're less than 52, so we're, you know, probably a good couple of 100 watts, maybe 150 watts from that. But what a beefcake of a thing, considering, look at the size of it. So yeah, interestingly, I shall just see if the pad is mentioned on here. Substrate ground. Well, anyway, it originally had a pad on it. It's going to have a new one now. But yeah, quite a comprehensive diagram. And, you know, there was enough in here that we'd have been able to fault find this without brute forcing it as we did. But glad we did spot that regulator cooking up. Glad I spotted the solder splash, because I think we've got a viable repair. Right, I'm just waiting for those parts. Right, I'm in receipt of a sheet of that blue phase changing stuff. I'm going to want a bit of a Sharpie. I just need to cut this down so it fits on top of the amplifier. So just going to mark it up a bit. That should do us. Just cut that out. Find my tweezers, peel the stuff off and get that on. Talk amongst yourselves. Yay! Right, protective piece off. That fits on there in a minute. Got the original backing piece there. This stuff doesn't need any extra thermal paste on it. It's that magical phase changing stuff, so we'll just go in without. Tighten that all down a bit. I'm not going to tighten it up fully, because I need to make sure it's in the right place with position on the back panel before I tighten it up. Looks pretty good. We want a squib of just ordinary therm path on that heatsink. So yeah, we just take that back out again. Now it was only on one side of that before, but I don't think that's adequate, so we should go all the way around this time. And we'll just get that put back together. Is that a countersunk screw? I can't remember. Yes, it is. Shake-proof washer. Cinch these up. That's lovely. That's managed to grip in. So that's good. Lovely. Okay, so now I am just waiting for that resistor, wherever it is, the 51 ohm down in there to turn up. So hopefully that'll be here any day. Right, I have procured some monstrous 51 ohm resistors, and I'm just hoping they're going to fit. Yeah, I think so. These are 10 watt parts, so yeah, that's going to be hopefully much better for our power dissipation on this board, and hopefully stop that resistor from getting hot and bothered. I mean, it's working within parameters, but obviously that resistor is just a little bit underrated, so I've gone completely the other way and utterly overrated it in the name of reliability. Right, let's get the power supply back out of there. Okay, right, 51 ohm resistor needs to come out then. Right, so to mount that way up in the board would mean that this leg isn't going to reach down far enough by the look of it. So what I'm just going to do is I'm going to form the leg rather round, and then join it up with the bottom one. Solder it together and then cut it off at the appropriate point. So just bend those round like that. There we go. It's only just going to be long enough even then, I think. Yeah, do you know what? I'm not going to do that, because that is only just long enough. And I want to stand it off the board a little bit if I can. Just let the sort of air circulate around it a bit. So yeah. So if that's the case, I'm just going to hold it down onto the bench and add a bit of tin copper wire to that leg. Let's put a loop on there. Get a bit of mechanical strength. There we go. And I can just cut that off there. Far too long now, but we can always make it shorter. Right, that's better. I should think that original resistor is probably only 2 or maybe 3 watts perhaps. So this should make quite the difference. There we go. And it's going to clear the top of the power supply, which I was not seriously worried about, but it could have been an issue. I am also going to bend these legs over like that and solder them left to right of these pads, because these pads are a little distressed. Oh, so much so I've just pulled that pad away again. Yep, these are very, very fragile. Just the heat's got to the board. At least by having that larger resistor in there, it's going to allow the same amount of energy to be dissipated over a bigger area, and therefore hopefully keep a little bit cooler. I've now damaged that pad, so I'm going to have to repair that now. Right, yeah. A little bit of the fiberglass pencil, clean that up, and I'm just going to put a wire link right back to where it joins up there. Right, let's just have a little clean up of the flux. I think this might be nearing the end of my can of IPA. I could put a bit of solder resist on there, but I don't think it's necessary. That track is not near anything else. Right, good. Let's pop it back together. While I'm just popping this back together, by the way, I'd just like to mention something because it's ever present in the comments and some emails I get, and I noticed we've got an awful lot of new subscribers. So you probably haven't seen the video entitled Google Hackaday and Neurology, and the neurology section of that video refers to my tremor, which is ever present in the videos and ever present in my life. Most people are very kind about it, people not so much, but I've had it long enough it doesn't bother me anymore. So it is it's not a serious thing, it is something I do. I shake. It's caused by an anti-epilepsy medication I take. I've been epileptic for many years, and yeah, it's something that does affect me. Now it's come to the stage of my life where I need to stop taking that medication. So yeah, I have to wean off it and wean onto a new one, and apparently that's going to cure my tremor as well. So that'd be good. Because I won't miss it, I'll be honest with you. So yeah, that's coming. It's currently the end of July as I record this. I should be getting an appointment through in August to start that process, and it is a process which is going to last for a number of months as they wean me off one thing and put me onto something else, and then hopefully I won't shake anymore. That'll be the best outcome I think we can hope for. Anyway, so yeah, that's why, just to put the concerned people's minds at rest. Don't panic, I'm all right really. Right, let's get some screws back in here. Okay, I think I might want to run some tests now, really. So I'm going to hook this up to the workshop loudspeaker. What I'm particularly concerned about is whether the automatic works. So that was one of Brian's concerns, that the auto function wasn't working. So bear with me one moment while I just set everything back up. Okay, right, I have got things assembled. The workshop test speaker is connected, just tacked it on the back of the board there. Old Faithful, if you're new to the channel by the way, Old Faithful is an ancient MP3 player. It's an Acer MP3 330 with a mechanical hard drive in it, but it's something I just use for testing. So let's hit play on that, and yes, I don't know whether that's coming out on the microphone because obviously it's a sub amp and I've got a high pass filter set on the microphone, but we have thumping and bassy noises. So yeah, that's looking good. Right, let's get it back together. Right, it would appear this only goes on one way. Not quite sure what's going on there, because that would appear to be right there, but the holes don't line up there, so it's just not quite square. So maybe we go around that way, but that does pull that connector really tight in there. Oh no, that is how it is. Okay. And there you have it, the Monitor Audio Mas W200 subwoofer, which I'm going to switch off. It's probably not coming up on the mic, but that's shaking the rafters. Anyway, thank you very much for watching. Click like, subscribe, do all that rubbish, and I'll see you really soon here on Doz's Television Workshop. Cheers now, bye.
Echoes lost in the amplifier's hum. Voices tangle in electric dreams. Wires twist and currents run as broken notes begin to stream. So loud, so loud. Silent cry for sound. Unreleased, take it to. Does this make it new? Where the circuits breathe in the heart of tunes. They'll revamp the beat. Broken chords, a fractured song, waiting on the counter there. Dozzy's hands will make it strong, revive the rhythms lost in there. So clear, it's done.